Welcome everyone. In today's lecture, we are going to learn when the big data meets SDN. The objective for this week is that at the end of this week or at the end of this lecture, you would be able to understand the basic characteristics of big data. We will also review the concept of SDN and the benefits that SDN can take from big data. On the other side, you would be able to list and explain the benefits that big data can take from the SDN. And finally, at the end of this lecture, we will explore some open research issues that are related with these two concepts. So the roadmap for this presentation is that we are going to start with the big data, its definition, characteristics, and then an overview of the SDN. And we will move our concentration to the meetup between the SDN and the big data and how they can benefit from each other. And finally, some open research issues. Well, big data has become one of the hottest topic. And this term big data, it actually refers to any collection of data that is so large and so complex that it actually exceeds the processing capabilities of our conventional data management systems and conventional data storage techniques. It can be defined as data sets, the size of which is beyond the capabilities or beyond the abilities of our typical databases and database tools in order to capture them, to store them, to manage them, and to analyze them. And this is going to be one of the important catalyst for the economic growth, as stated by the McKinsey report. According to the McKinsey report, one of the opportunity that actually contributes to the launch of the big data era is the growing torrent of the data. Torrent means a stream of water that is actually flowing with great speed and sometimes with violence. So this actually refers to the idea that data seems to be coming continuously, rapidly, at a very fast rate, and we need to store that data, we need to process that data, we need to make sense out of that data. Now, a basic question is that from where this big data is actually coming from. We all actually generate big data. For example, consider your WhatsApp status and tell me how many messages you could actually send to your friends and family in the last week. Similarly, how many videos you have watched on YouTube and other streaming websites. How many tweets actually you you send or you watched. How many emails actually you sent, how many emails actually you read, how many emails actually you received, how many images you uploaded on websites, social media like Facebook, like Flickr, etc. How many likes you have given to the photos that was posted by your friends. How many music you were able to download or to listen online. How many articles you actually read. How many classroom recording you actually watched in the last week. And how many Google Classroom, Google Meet live session or Zoom live meeting you have attended in the last week. So you as an individual is actually producing a large amount of data. So in summary, big data, we can say that it can be generated by machines, by human beings, and by organization. Uh, sorry. With machine generated data is actually in most of the cases from sensors. Sensors are installed in our homes, in our vehicles, our smart devices, gadgets, offices, everywhere. And they are able to sense the environment and also report the reading to a nearby station. Let me give you an example. What do you think a flight from Pakistan to United States, how much data would be generated by that aeroplane? So absolutely, the flight would be able to produce even terabytes of data every time it flies from one country to another country. Because there are plenty of sensors on the plane and they have to update about the status of the flights and different parts of the plane to the ground team constantly. So this is an example of machine generated data that is actually coming from the sensor. Okay. Other examples of machine generated data are the data generated by our smartphones, for example, our location, where we go. And for example, if you are going for an exercise like running or walking and you have an app downloaded, so you're actually generating data. Each step that you take will actually generate the data. Similarly, smart vehicles is another example. Drones, gadgets, Internet of Things, etc. So all these are examples where machines are generating data. The second factor is people, human being. As I just mentioned, we are generating massive amount of data every day through our activities on various social media networking sites like Facebook, Twitter, LinkedIn, etc. Or maybe photo sharing websites like Instagram, Flickr, etc. Or video sharing or streaming websites like YouTube, etc. So in addition to these, an enormous amount of information gets generated from the text, like blog websites, comments that we actually put on things, searches, how many searches do we actually perform on Google, for example, or how many text messages or email based on text that we are actually communicating, etc. So most of this data is text heavy and also it is unstructured. Unstructured means that they are not conforming to a well-defined data model. Okay, so these activities leads to huge growth in the data. And the size of this unstructured data that we are actually generating brings a lot of challenges to the research community. So in summary, we can say that human is another factor. They actually generate a huge amount of data, and that data is in most of the cases unstructured data and mostly in the form of text, which means there is no given format to that data. And there was a survey in which it was mentioned that about 80 to 90% of all the data in this world is actually unstructured. And this number is growing rapidly. So as a summary, there is an enormous amount of data generated by the people, and most of the data is actually unstructured. So we need emerging technologies to handle these problems, the huge amount of data, and also to handle this unstructured data. One of the tool that is very much famous to handle large and unstructured amount of data is the Hadoop. And it is designed to support the processing of very large data sets in a distributed computing environment. and it has other built-in components like the Storm, like the Spark, like the MapReduce, and things like that. Finally, big data can be generated by different organizations. Okay, for example, there are many commercial transactions that actually occurs inside the organizations, like credit cards, government institutions, e-commerce, banking, stock exchange, etc. Even your medical records, they are actually generating data. So organization actually store this huge amount of data, and they need to store this huge amount of data for current and future for future use, as well as for analysis purposes. But the problem is again how to deal with such a huge amount of data. Now let us, after defining the big data and who is actually generating the big data, let us see some big data V's. Normally the big data is characterized by using a number of V's. Initially there were 3 V's, and they were volume, the second one was velocity, and the third one was variety. And then later on we have added another V, that is the veracity, and after that we have added other V's as well. So we are going to discuss these V's. First is volume. Actually the volume refers to the vast amount of data that is generated every second, every minute, every hour, every day in our digitized world. Another thing is velocity, and it actually refers to the speed at which the data is being generated and the pace at which the data moves from one point to another point. The third one is variety, which actually refers to the ever-increasing different forms that data can come in. For example, sometimes the data is in text form, sometimes it is in image form, in voice form, geospatial data, etc. So data can take different forms. So as I just mentioned, more V's were added, were introduced to the big data community. And one of them is called veracity, which actually refers to the biases, or you can say the noise or abnormality in the data. So it can actually refer to the unmeasurable uncertainties and truthfulness and trustworthiness of the data, things like that. Beside from these 4 V's, we also have another V, the fifth one, which is called Valence, which actually refers to the connectedness of big data. And finally, we have another V, that is the sixth V, and that is the value, which is like the heart of the big data. And that means how big data benefit you and your organization. So let me shed some more light. The first one is volume of the data, that is the scale of the data. And actually the volume in the big data context, it actually relates to the large size of the data. We will see some statistics in a moment which will show that every minute a huge amount of data is being generated on the internet. And the size and the scale of storage for big data can be massive. Now the question is, how do we utilize large volumes of data to improve, for example, our end product quality? So there are a number of challenges that are related to this massive volume of big data. The most obvious challenge is how to store the data. As the size of the data increases, so does the amount of storage space required to store the data efficiently. However, we also need to be able to retrieve that large information. Not only storage, but retrieval is another challenge. How to retrieve that data, and also to retrieve the large amount of data in a speed fastly. And also, if we want to move it for processing unit to processing unit, then we need to move the data in a timely fashion. And also, if we need results, we need to get the results, analyze the data as well, quickly and fastly. Okay. So these things also bring challenges to other things like networking, like bandwidth, like cost of the storage of the data, like uh, processing of such large data and things like that. So there is the volume and the challenges related to the volume. The second one is velocity. Velocity of big data actually refers to the increasing speed at which big data is created and the increasing speed at which the data needs to be stored and analyzed and moved. Processing of data in real time to match its production rate as it gets generated is a particular goal of big data analytics. For example, this type of capability allows for personalization of advertisement on the web pages. There is one example. You visit a website recently, and then in real time, the website will display the advertisement, personalized advertisement based on the content that you have searched on the internet. So if a business cannot take advantage of the data as it gets generated or at the speed analysis, if they do not do the analysis in a rapid way, in a speedy way, then they can miss opportunities. They would not be able to present the personalized advertisement. So it's more important to match the speed of processing with the speed of the information generation and get real-time decision-making power. The third one is variety. Variety is actually the scalability. However, in this case, scale does not refer to the largeness of the data. It actually refers to the diversity of the data, increased diversities, and also the complexities that result from more kinds of data that we actually need to store, to process, to combine, to move, to send, etc. We always thought of data as tables, relational databases, and these tables could be like in spreadsheet or in a database application or maybe even in file, but somehow they will be modeled and manipulated and rows as rows and column of the table. However, today a much wider variety of data are collected, stored and analyzed to solve our real world problems. So we have to deal with image data, text data, network data, geographical maps data, computer generated simulations, augmented reality type data, just to mention a few examples. So variety of data is a big challenge. And after that, we have another V, and that is called the veracity of the data. The veracity of big data actually refers to the quality of the data. It sometimes gets referred to as the validity of the data or volatility uh, to the lifetime of the data. So veracity in simple word is actually the quality of the data, and it is very important for making big data operational because big data can be noisy and it could have uncertainties. It can be full of biases, abnormalities, and so on, maybe imprecise. So data is of no value if it is not accurate. The results of big data analysis are only as good as the data being analyzed. So we can say that although the big data can provide many opportunities to make data enable decision, the evidence provided by data is only valuable if the data is of satisfactory quality. And there are different ways to define data qualities in the context of big data. For example, quality can be defined as a function of a couple of different variables, like what is the accuracy of the data, what is the trustworthiness of the data, what is the reliability of the data, and things like that. Beside from these four V's, we have another V, and that is known as valence. And valence actually refers to the connectedness. The more connected data is, the higher its valence is. Data items are often directly connected to one another. For example, a city is connected to the country it belongs to. Two Facebook users are connected because they are friends. An employee is connected to his workplace, a student is connected to the university, and so on. So data could also be indirectly connected. For a data collection, Valence measures the ratio of actually connected data items to the possible number of connections that could occur within that. And finally, we have another V, that is the value, and that is at the heart of this characteristic, the value of the data. So at the heart of the big data challenge is turning all of the other V's, all of the other dimensions of big data for the benefit of the organization. That is going to be truly useful for the organization. And the idea behind processing all this big data in the first place is to bring value to the problem at hand and value to your organization. Okay, so these are some statistics that I was talking about, that how much data is actually produced every minute. And these statistics are from 2019. I'm sure some of them may have double, or some of them may have an increase up to 10-20% in 2021. So you can have a look on these later on. Let's move to the next concept. We are going to meet up these two concepts, big data and SDN. So we talked about the big data. Now let us shed some light over the SDN. We all are familiar with the SDN concept because we have spent more than 6 weeks on this topic. But in order to relate them with the big data, so big data applications would not be possible without the underlying support of the networking. And SDN is a type of network which has attracted great interest as a new paradigm in networking. And as we know that in the SDN architecture, the control plane and the data plane, they are decoupled. Means network intelligence and state are logically centralized now. And the underlying network infrastructure is actually abstracted from the applications. And the main idea of SDN is to detach the control plane from the forwarding plane. Okay. And in SDN, decisions are made by the network brain, and it has a global network view. And this global network view actually eases network optimization and performance. In the SDN data plane elements, the switches, they become highly efficient and programmable packet forwarding devices. While on the other side, the control plane elements are represented by a single entity, and that entity is the controller. If you compare SDN with the traditional network, it is much more easier to develop and deploy different applications in the SDN. And in addition, with the global view of the network in SDN, it is straightforward to enforce consistency of network policies. Different types of policies can be easily implemented. Now let us see how actually these two concepts are merged together. SDN will have significant impact on the big data applications. In particular, several good features of the SDN, for example, separation of the control and data plane, a logical centralized control, a global view of the network, and programmability, ability to program the network, can greatly facilitate the big data acquisition, transmission, storage, processing, movement, and things like that. For example, A big data is usually processed in the cloud data center. And compared to traditional data center, SDN-based data centers can have better performance by dynamically allocating resources in data center to different big data applications. Okay, so we are going to see what are the benefits that we can actually get from them. On the other side, these were the benefits that actually SDN will get from big data. On the other side, big data will also be able to receive several benefits from the use of SDN. So big data is an important network application, will have profound impact on the design and operation of SDN. Specifically, as we know that SDN provide us a global view of the whole network. And we have the logically centralized controller in the SDN. And it can obtain big data. The SDN controller can actually obtain or get big data from all the different layers, like the physical layer and above the physical layer up to the application layer with arbitrary granularity. And also there is a concept which is known as the cross-layer design. So in cross-layer design, although sharing information among different layers, there have several researches which demonstrate that the cross-layer design actually improves the network performance. However, on the other side, if we are using the cross-layer design in the traditional network approach, then it will make our network more complex. And our traditional approaches would be inadequate to design and optimize these networks. So fortunately, the big data analytics, which leverages analytical methods to obtain insights from data and to guide decisions, it will actually help the design and operation of SDN. For example, with the big data analytics, normally the traffic analysis, it is easier for the controller to perform traffic engineering to improve the performance of the SDN. So let us actually see how we can get benefits from big data if we are using SDN. So from one side, we are going to see the benefits that SDN can get from the big data. So these are some benefits that you can see here. On the left hand side, we have the features of the SDN, and on the right hand side, we have the benefits that we can actually get. What are these benefits? The first benefit is that big data processing in cloud data center. The second one is data delivery. The third one is programming at runtime is possible. And support for scientific big data applications or architectures. And finally, we have the Hadoop scheduling. Let us see them one by one. The first one is big data processing in the cloud data center. Big data is usually processed in the cloud data center. I told you earlier that big data and cloud computing, they are very much interlinked with one another. So, and normally we use the concept of data center as well. So these three concepts, big data, cloud computing, and data centers, they are actually linked with one another. And big data is usually processed in the data center, and the data centers are somewhere in the cloud. So it is important to assign and manage resources of cloud data centers efficiently so that we can meet this SLA, the agreement of different big data applications. What is SLA? It is actually an agreement negotiated between a big data service provider and a big data user. For example, it will define the response time, or maybe the processing time, or what is the rate of failure, what is the level of trust, what is the security, privacy, negotiation time, maintenance time, cost, amount of data processed, data received, amount of data emitted, quality of the data, input, output, time consumed, etc. Many things come under the umbrella of SLA. Now, the technology trend of cloud computing is putting pressure on the data center providers. What is that pressure? Data center providers need to create more flexible services with better network performance and security. That is the pressure that is put on data center providers. Now, with the SDN enabled data center, which is a futuristic approach for the data centers, the networking and the storage infrastructure is delivered as a service. Remember, in the cloud, we have to offer services like infrastructure as a service, storage as a service, platform as a service, application as a service, and things like that. So with SDN enabled data center, a futuristic vision, the networking and the storage infrastructure is delivered as a service. And that thing is also automated by the SDN. So from the perspective of infrastructure, the cloud platform is built on the basis of the data centers. And the data centers are known as cloud-based or cloud data centers. Our second benefit is about data delivery. Due to the large volume of data, data delivery in the application is a great challenge. You have a huge amount of data. How you would be able to deliver that data to the end user, for example? So recently, SDN based optical networks, we talked about optical switches in the previous lecture. So SDN based optical network is proposed by several researchers, and such architecture actually accelerate, and they also give support for the delivery of traffic for big data applications. You can combine unicast, multicast, broadcast, etc. So big data application have lead to massive volumes of traffic, and they actually feature diverse communication patterns. Like, as I just mentioned, it could be the communication pattern could be unicast, could be multicast, could be all cast, could be broadcast, etc. So in the literature, different solutions have been proposed to address this, and one of them is a hybrid solution. There is actually the combination of optical and electrical switches that actually leverages the physical layer optics to accelerate traffic delivery for different patterns. Oops. Yes. So the application driven control plane is actually compatible with these architectures. You know, in the SDN we have a control plane, and on top of control plane we have the applications. And though the control plane is actually managed by the application, so the application driven control plane of such architectures is actually compatible with the SDN, and this will enable flexible and dynamic runtime configuration of the devices to support different complex traffic patterns and to deliver big data. Our next benefit is the optimization of the big data applications. As we know that we have now very frequently changing environments, and due to this ever-changing environments, many big data applications require frequent reconfigurations. And we know that SDN, which are programmable networks, they have the capability to do the programming at runtime and also do it in a very useful way. And this is going to be very useful for the big data applications because big data application will require frequent reconfiguration. In order to study, sorry, in order to study the integration between the big data application and the network control, normally a cross-layer structure is proposed, and that is based on the SDN. So we can say that the programming of SDN is actually explored across the layers of a network, starting from the physical topology to routing and flow level traffic engineering and stuff like that. So many solutions have been proposed that actually combine the SDN controller and optical switching to realize close cooperation of the network control and big data application in order to achieve optimizations. Next benefit is about the scientific models or scientific architectures. Scientific research is highly data driven. Some scientific research instrument, they actually produce enormous amount of data. If you search Google, you will find that big data is in the astronomy, it is in the medical sciences, it is in the physics, in the geosciences, etc. So it is everywhere. So scientific research is actually highly data driven now. However, there is a problem. Due to some political and technical reasons, some scientific big data cannot be processed and analyzed at the same location where they are generated due to security reasons. So the big data has to be sent to various data centers, or maybe it could be sent to researchers working at different universities or institutions for analysis. However, our current campuses networks, they are not capable of handling such huge big amount of data. As the amount of data increases, there is a greater need for scalable end-to-end network architectures and also implementation that will enable the application to use the network efficiently. Okay, so a big data architecture model has recently been proposed to address this problem. And this new architecture model for campus network, they actually uses SDN as a possible solution. And they will allow the multi-science discipline within the same campus network to work on the data and to analyze the big data. Next application is related to Hadoop. So how SDN can benefit from big data in the context of scheduling? As we know that Hadoop, as I just mentioned, is an integrated platform for data storage, processing, management, and it has other modules to form a powerful system level solution to handle the big data and resolve the big data challenges. And it is very popular in research community. However, there is a problem in Hadoop, and that problem is known as NP completeness. We will not go into the details of that problem, but this problem has significant impact on the performance of Hadoop system. And this problem needs efficient solution. And the solution is how to minimize the job completion time in the Hadoop system. However, majority of the current solution to address this problem are not optimal because they do not have a global view for task allocation. If we use SDN to address this problem in Hadoop, we will have a global view of the network available. So specifically, SDN based network could help us to solve this problem, this classical problem in the Hadoop. Okay, these were some benefits that actually SDN can get from big data. Now let us move to the next part of the picture. How big data can benefit from SDN. There is another angle. An important aspect is traffic engineering. And this is a method of optimizing the performance of a network by dynamically analyzing the network, predicting the resources, regulating the behavior of data transmitted over the network, and things like that. So we can say that the objective of traffic engineering actually include balancing the network load in order to maximize the network utilization. Now, SDN and big data analytics provide a convenient and effective way to perform traffic engineering and improve network performance, even on a larger scale. And we have studied about the traffic engineering in our previous lecture. So the point here is that SDN based network actually they will have to deal with 100 or even 1,000 of hosts with significant bandwidth requirement. So what I mean to say is that traffic engineering is going to be a problem, a challenge in SDN network. So if we are able to combine the big data and SDN for traffic engineering, we will have a solution that will have many advantages. For example, it is going to be relatively easier to obtain big data traffic information because we have a logical centralized SDN controller. And also the flow format of big traffic data with arbitrary granularity can be exploited for traffic engineering. And also it is going to be relatively easier to apply traffic engineering results to switches in a data center by modifying the flow tables within the switches themselves. Here we have an example. This figure actually describes a dynamic traffic engineering system architecture. And this architecture has SDN and big data. And you can see it actually consists of 4 components: a data center network, an SDN controller, a traffic engineering manager, and big data applications. In the data center, there are many servers and many SDN switches or maybe routers, which is considered to be a target network of the traffic engineering system. The SDN switches and routers in the data center network report their big traffic data and also other status information to the SDN controller through this interface, through this API. The SDN controller will aggregate and summarize the collected big data information and will send it to the big data applications. Now, big data analytics, which leverages analytical methods to obtain insights from the big traffic data, then give guidance to the traffic engineering manager, which derives the traffic engineering policies. According to these traffic engineering policies, the SDN controller changes the switches behavior of the SDN devices by updating, for example, their flow table, or maybe turn on and turn off, and links in the data center to minimize power consumptions and maybe link congestion, things like that. Next benefit is about the benefit that we can actually get from the cross-layer design. So we can say that big data can also benefit from other layers in the SDN. Traditionally, if you revise, our network is divided into different layers, and a set of protocols are used for communication between adjacent layers. Like we have the application layer, then we have the transport layer, then we have the network layer, and so on. So in traditional layer design, it is forbidden to have direct communication between non-adjacent layers. If the layers are adjacent one above the other, then they can use the services. But if they are not adjacent, then they cannot have a direct communication. However, recent advances in the cross-layer design show that non-adjacent layers can actually share information during runtime. And this information sharing will result in new algorithms, and it will improve performance in networking systems. So although, as we just saw previously, it will improve the performance, but the principle of modularity is broken. And also the network will become very complex. And as a result, our traditional approaches would not be able to deal these situations or to optimize such networks. But fortunately, big data can benefit from the cross-layer design in SDN. The logically centralized controller in the SDN, as we know, it has a global view of the network. And this global view will enable it to obtain big data from the different layers, such as the channel state information at the physical layer, packet information at the data link or network layer, and application information at the application layer, because it has a global view. So it has access to information at all layers. So applying the big data technologies to network control and management can significantly improve the network control and management processes. Therefore, cross-layer design is in SDN is a good solution, but it's going to be challenging as well. Here we present an architecture of combining big data and SDN, which can facilitate the cross-layer design in SDN with the help of big data. There are 3 layers as usual: the infrastructure layer, data processing layer, and data processing and control layer, and the third one is the application layer. The infrastructure layer, as we know, consists of switches, routers. It consists of servers, data center devices, and things like that. The switching devices actually transfer data packets to the next hop in accordance to the rules that are defined in the forwarding tables, and they are stored in the local memories. In the data processing and control layer, we have the SDN controller, as we know. And we also have another component that is the Hadoop, because we are dealing with big data. So Hadoop will have close cooperation with processing the big data and making the decisions together with the SDN controller. So the SDN controller provides Hadoop with the cross-layer information that it obtains from all different layers, while Hadoop provides the SDN controller with network control strategies like physical layer parameters, adoption rate, resource allocation, topology construction, routing mechanism, congestion control, etc. And this will optimize the performance of the network. So both big data applications and networking applications that actually run on top of this data processing and control layer, they can actually benefit from this setup. Another benefit is that of security of the SDN, because security of the SDN is a big concern. Since SDN is split into 3 main functional layers, so it means that malicious attack can be launched on these 3 layers of the SDN architecture. So based on the architecture, the 3 layers, we can categorize the attacks into application layer attacks, control layer attacks, and infrastructure or data link layer attacks. These attacks are shown in the figure. There are two methods to launch application layer attacks. One is attack some applications, and the other is to attack the API, and that API is the northbound API. The controller could potentially be seen as a single point of failure, and this will affect the whole network. So it is particularly attractive target for the attackers to attack this controller in the SDN architecture. Some methods that can launch control plane attacks are like attacking the controller or attacking the northbound API or even the southbound API, because controller has access to the northbound API, or it has access to the applications with the help of northbound API, and access to the switches with the help of southbound APIs. So an attack could be against the controller itself, or it could be either side of the APIs. And there are two methods to launch infrastructure attacks. One is to attack some devices, some switches, some routers. The other is to attack the southbound API. Some attacks like distributed denial of service attack take advantage of botnets and other high-speed internet access technologies in order to let the whole network down. So the application of big data analytics to mitigate security attacks, to handle these types of security attacks or these problems, is becoming more and more attractive. So the ability of big data analytics enable us to comprehensively analyze a large volume of complex data from different sources and even in different formats. We can compare these data and we can perform anomaly detection and combat these threats in real time if we are using the big data analytics. So big data analytics can also provide correlation methods among heterogeneous security data, but we will not go into the details of that. Okay, next let us see some open issues, and this is the last slide. The first open issue is scalable controller management. If we want the SDN to have a commitment with the big data, then we need to address the issue of scalable controller management. Why? Because when the network controller in the SDN is used for big data applications, its performance could be degraded. Why? Due to the rapid and frequent flow tables update request, because we are dealing with big data. Okay, so we have the flow tables and the entries are going to be updated frequently, and also they need to be transmitted frequently, processed frequently. So accordingly, the network controller should be designed in such a way that it can accommodate larger flow tables and big data. Because I was reading in an article that the current controller flow tables have around 8,000 entries, which are insufficient for big data operations. So the design of a scalable network controller for big data applications need to be explored further. One possible solution is that a cluster of controllers can be used, and we have seen it. We are not using a single controller, we are using a cluster of controllers. And that could be like, it can solve the scalability issues. Another way to deal with the problem is to employ parallel computing in multi-core systems and improve the I/O performance. The second challenge is related with the flow table. As we know that the main motivation of designing SDN is to simplify the switching devices. How? By separating the control plane from the forwarding plane, and then transforming the intelligent to the control plane itself rather than the data plane or the forwarding plane. In the joint design of big data and SDN, forwarding tables are sent to the switches in the network, And the switches utilizes these forwarding rules to transfer data packets of big data applications. However, since these networking switches do not have any intelligence, who has the intelligence? The controller itself. So they just send raw data packets to the network controller. In other words, no data pre-processing is done in the switches, which results in heavy load in the controller. Therefore, if we introduce some intelligence in the forwarding plane of SDN, that is going to be a great thing for big data applications. The third issue is the need of a language abstraction. A common high-level programming language in SDN is still missing, especially for big data applications development. Currently, different controllers use different programming languages. As we have seen in the previous lectures, that there is no well-defined standard for the northbound APIs. So we have different solutions available like POX, which uses Python, Beacon, which uses Java. So SDN actually requires a common programming language that should be able to adapt to frequent flow rules changes caused by the big data applications. And finally, we have the wireless mobile big data. So SDN has been studied not only for the wired network, but also for the wireless mobile networks like the cellular networks, 4G, 5G, or upcoming 6G, and also the VANET vehicular network, FANET flying area network, and sensor networks, ad hoc networks, etc. So SDN-enabled wireless mobile networks will bring some promising features like easier deployment of new services, reduced management and operational cost of heterogeneous technology, efficient operation of multi-vendor infrastructure, increased accountability, and things like that. So with the rapid deployment of wireless mobile network, more data are now collected from the mobile devices. Therefore, more research should be conducted to study the benefits of SDN for big data applications in the wireless mobile networks. That is going to be like the integration of the three things: big data, SDN, and mobile networks. So let me conclude. Joint design of the big data and SDN can become a promising solution for big data networking and applications. Now, how to make full use of SDN advantages to improve the performance of big data application, and how to utilize big data to make SDN work better and more efficiently are the burning issues that need to be addressed. Thank you so much for watching the lecture. See you. Till then, goodbye and take care of yourself.